Okay, great, thanks. Hi, everybody, welcome. Thanks for joining us here to learn about civil engineering. We're really happy that you're with us today, and we hope through our presentation and conversation that you gain a better insight into what civil engineering is all about and what civil engineering means here at Purdue University. In addition, what types of projects that you can work on as a civil engineer. So we're going to start off by introducing ourselves. So I'm Sue Khalifa. I'm the Director of Student Experience here at the Lyles School of Civil Engineering. I am a civil engineer and my background is in structural design of buildings. I worked up in the Chicagoland area for a number of years designing buildings of all shapes and sizes. So I'm going to let Whitney and then Cal introduce themselves.
Hi, I'm Whitney. I am a civil engineer as well. Obviously, all of us here are. And I am in drinking water. That's where I work. I work in Indianapolis at a consulting firm. So I do drinking water stuff all day long, design water treatment plants and water distribution systems, and go out and watch them get constructed.
Hi everyone, my name is Callahan Murray. I work for a general contractor, which is actually headquartered at Evansville, Indiana, but I'm on a project down in Houston, Texas. Graduated a couple years ago in the civil engineering program, and then I went more the construction route. So Whitney could probably talk a lot more about the design side of things. I can talk a lot more about the actual implementation of the design and stuff like that.
Great, thanks guys. And now I'll let the current students introduce themselves.
Hello, I'm Jasmine Walker. I'm a junior here. I'm from Chicago, Illinois, and I am studying architectural engineering.
Hi, my name is Caitlin Hopper. I'm a senior in civil engineering with an emphasis in structures. I also have a minor in building information modeling, which is through the CGT courses on Revit. And I actually just accepted a job as a structural engineer for LJB Inc., which is over in Dayton, Ohio.
Hi everyone, my name is Anthony Fan. I'm a senior studying civil engineering with a concentration in transportation and infrastructure systems. I've had a couple experiences with internships and co-ops in the past, and this past summer I worked with HNTB in Chicago working on the O'Hare Airport, and we'll be continuing that next summer.
Hi everyone, my name is Camille Hamilton. I'm a junior from Oklahoma. I am majoring in civil engineering with an emphasis in transportation and construction.
Great, thanks everybody. And we'll hear from everyone throughout the entire time we're together. So if you all have any questions, please place them in the chat. We are monitoring the chat live and we'll respond. And if we see some questions that keep coming up, we'll also bring that up and talk about them. So, okay, so as civil engineers, the work we do makes an impact, right? We make an impact in our communities, and we do this by designing and building systems that work to improve the infrastructure that we all use on a daily basis. So as civil engineers, we design systems that allow people and goods to move safer and more efficiently. And what that means is we're working on systems such as work on public transportation systems, right? So here we can see a train system, right? We also work, again, to move people and goods and things like harbors and ports, right? You order something on Amazon, you get it in a day or two. It's because civil engineers are doing their jobs in helping goods move from one place to another. We're also heavily involved in the railway industry, again, moving people and goods. And also, what some people may not know is heavily involved in the air travel industry, so design of airports, but also air travel and air transportation systems. We also work to design systems such as roads and roadways to get people and goods from one place to another, and additionally work on things you might not even think of, like bike transportation. That's also a piece that we as civil engineers work on. And we also allow people and goods to move around efficiently and safe through our involvement in design of bridges and systems. And we do more. What we want you to get out of this presentation is that civil engineering is really, really broad and diverse. So we also work on systems that provide safe forms of shelter. So that could mean anything from a single family home to a multifamily residential unit, to things like high rises, office buildings, that sort, to educational facilities. So it could mean, things like universities, right? Other school systems, to even such structures as stadiums, right? Places where we work on providing safe forms of shelter for where we live, where we work, where we play, and more. And there's more. We also work on systems that protect our coastlines and waterways. So we are looking at our coastlines. We are trying to protect them from erosion. We're also trying to protect our natural waterways. So rivers, streams, lakes. And we also work on and create human-made waterway systems like this canal system down in Indianapolis. And there's more. We also work on systems that supply cleaner forms of energy. So things like solar farms, very common for civil engineers to work on, wind farms, hydroelectric plants, in addition to geothermal systems, right? So using the ground as an insulator. And we also work on systems like Whitney was talking about, systems that provide clean water and sanitation. So when you turn on the faucet and clean water comes out, that's thanks to a civil engineer. And then that water goes down in your drain and out, and it comes to a place where we go ahead and then we take care of it and we treat it. So this is hopefully a high level view of some images that give you an idea of what we as civil engineers do. And so now I'm going to transition into, what does civil engineering mean at Purdue, right? So we talked about civil being really broad and diverse, and you can see that here. So in the program in our program here, we have 9 emphasis areas, and we'll talk about all of those. But if you can't or choose not to decide on any one in particular, you can remain general. So you can learn a bunch of different topics and remain more general. So I'm going to now let everyone talk about the different emphasis areas here. So Jasmine, go ahead on architectural.
Yeah, so the architectural emphasis focus energy efficient and sustainable built environments while optimizing human comfort. So this deals with everything inside the building envelope, which deals with the mechanical, HVAC, electrical, and lighting systems, as well as the indoor air quality and environment.
Cal, tell us a little bit about construction.
Yeah, so construction is a lot more of the implementation of the actual design. Pretty much you get, your signed and sealed drawings at the end of the day. And then the time-old question is how we're going to build this and how we're going to build this as effectively and cost efficiently as possible. And, the entire time, got to make sure that, you're following environmental standards, you're following, safety protocols, all that kind of stuff. And making sure that you're not going completely over budget at the same time. So construction is kind of going from point A to point B, which is never really as easy as it seems. But yeah, so all the things on here are things that you're going to be doing, ensuring quality, ensuring all that kind of stuff.
Great, thanks, Cal. Whitney, can you shed some light on what environmental means in civil engineering?
So environmental for civils is kind of like the cross between what an environmental engineer would do if they were purely an environmental engineer and what a civil engineer would do. Basically, they're in charge of making sure that designs meet the standards of whatever agency that you are following. So in the United States, it would be the EPA. Additionally, they are in charge of creating designs that better our environment in general or are sustainable. So they will work with water, air, and soils to make sure that everything is good for the environment.
Great, yeah, thanks. So we're going to break it up now. And Anthony, why'd you choose civil engineering and what do you love about it?
So from a young age, I was really interested in buildings, architecture, as well as like airports and airplanes. This is from since like I was third grade. I always knew I wanted to be something to do with like design and buildings. And so when I first entered Purdue, I was actually stuck between deciding between civil engineering and aerospace. And my first instance of like realizing like I wanted to specifically focus on civil is actually Industrial Roundtable. I went as a freshman and talked to a couple of companies under the assumption that I want to go aerospace, and I was very overwhelmed by all the big companies, all the long lines for aerospace and how competitive it was. And so in the back of my mind, I was like, well, I still love buildings very much, so I'm gonna go try to look for civil classes, and that's kind of how I was able to enter civil, and it was the best decision I've ever made because I love just learning everything about structures and buildings. And then I learned eventually later down the line that I can kind of marry both of my interests with airplanes and buildings by working on airports. So aviation design, aviation engineering is something that I'm working on right now with my internship. So I found that there's a lot of broad opportunities, a lot of great opportunities to pursue what you're really interested in within civil.
Great, thanks, Anthony. So Camille, can you tell us what geomatics means or what it is for civil engineers?
Yes, so geomatics really is anything regarding landforms in a sense. So within geomatics, you design, develop, and operate systems to collect, analyze, and use the geospatial information about land, infrastructure, oceans, natural resources, and the environment.
Great, thanks. Sorry, Jasmine, you want to tell us about geotechnical engineering?
Yes, so geotechnical has anything to do with basically any part of the building that touches the ground. So it's the analysis and design of foundations, slopes, retaining structures, and other systems that are made or supported by soil and rock. So before construction even starts, you need to go test the soil to make sure that the strength is enough or compatible with the materials that you'll be using and the weight of the building.
Great, yeah, thanks. All right, Whitney, you're up again.
Yeah, so this one's my favorite. Hydraulics and hydrology, it's basically everything having to do with water. There's 3 different types of water systems. You have drinking water and taking water supplies and creating them into a drinkable, potable system. And then you also have rainwater and stormwater, making sure that floods and big storm events are all controlled. And then you also have wastewater. You know, what happens once everything goes down our drains, once those storms do happen, you know, how do we get it back into our system to kind of be recycled? So that's basically everything that touches those 3 things are hydraulics and hydrology.
Cool. Okay, Jasmine, you're back up. Why did you choose civil engineering and what do you love about it?
Yes, so I chose civil engineering because from a young age, I've always loved to play with Legos, and I'd always build these like big skyscrapers, but I didn't want anybody to touch them. Like even if you needed the Lego piece, I didn't want you to like mess up my skyscraper. So I also took a lot of trips out of the country, so I got to see different architectures from different times, like the 1500s, 1600s, and it just kind of made me fall more in love with architecture. But I also love the engineering side of things, so that's where I kind of married the two with architectural engineering. And what I love about it is how diverse civil engineering gets to be. So last summer, which I'll talk about later, I actually had a to do different things that I've learned. It's so broad and diverse. I get to jump around in different things, still under the umbrella of civil engineering.
Okay, great. Anthony, you want to shed some light on what materials is in civil?
Yeah, so within the School of Civil Engineering, materials engineering uses engineering and science to improve the current materials and create new ones. And so there's a lot of obviously there's a lot of materials that goes into construction and civil, so that includes masonry, asphalt, bituminous materials, concrete, and more. This is a little bit different from materials engineering, the major, that's a separate school, because within the schools of engineering, materials engineering, the concentration focuses on construction materials. And so these are kind of the things that you'd be working on, different types of like concrete strengths and testing of that. There's a lot of labs and stuff within civil department that you get to do hands-on lab experiments in terms of materials.
Great, thanks. Caitlin, you're up, structures.
Yeah, so structures, or the emphasis within civil engineering that is structures, deals with creating structures that are both safe, stable, and also comfortable and feel safe for the users that are going to be using them. And that can be anything from buildings to bridges to exit ramps to retaining walls. I mean, there's all sorts of different structures that we encounter day to day. And the really neat thing that I've learned about structures is that it can be implemented in any part of the design process. Obviously, the initial design of a structure is an area that a lot of structural engineers deal with, but they can also be really involved with the construction side of the design process, where they have to make sure that the building or structure is going to be stable throughout all parts of the construction process, because you can't start building something and then have it fall down in the midst of trying to build it. But they also can be involved with fall protection within the construction side of engineering, which I've learned a little bit about with the company that I'm about to work with, that you can, one of the positions that they have is they travel around to different construction sites and develop fall protection that is structurally safe and sound for the construction workers while they're working on different parts of the project. And then also structural engineering is really involved with the renovation, maintenance, and renovation and maintenance, I guess, portion of the design process, when certain things need to be fixed or assessed to see if the damage is structurally safe or not. So they can be really involved in creating new alternatives and ways to fix problems in structures to make them safe again, or to safely renovate them to make them purposeful for whatever the new design is. So they are really involved, and it's really versatile area of civil engineering.
Great, thanks. Okay, Anthony, why don't you round it out with transportation?
All right, so with the transportation concentration, this specific field focuses on ensuring the safe and efficient movement of people and goods. So this includes any type of transportation you can ever think of. So road, railway, this includes public mass transit, bus systems, light railways, trains, cars, planes, boats, oh my, all the above. And so a lot of what Purdue transportation engineering focuses on is infrastructure systems and highways. That's because we're living in Indiana and there's a lot of highways, and America is built on highway systems. So you look at like different traffic analyses, asphalt and concrete construction of roadways, but then there's also like all these other different types of methods of transportation you can also focus on. It's like, as mentioned specifically, I'm looking at aviation, but you can also look at into public mass transit, and there's other things I mentioned before. But this one's a very broad one. A lot of different really cool stuff going on, a lot of different research opportunities and undergrad research opportunities here at Purdue.
Great, thanks. Okay, Camille, why did you choose civil, and what do you love about it?
Okay, so I always knew that I really liked math and science, but I really didn't know what I could do with those interests. And so I was fortunate enough to attend a pre-engineering academy. I was in high school for 3 years, where I was introduced to multiple different engineering types, ranging from aerospace, mechanical, computer, chemical, and then I had a civil engineering course, and just where I instantly fell in love. We worked with concrete in the Department of Transportation. And so when I was looking into colleges and what I wanted to major in, I instantly wanted to go into civil engineering with a transportation emphasis. But within Purdue, they give you such a great opportunity to look at all different disciplines in civil, and it is such a broad field. And so it's able to actually broaden my perspective. And I would say the reason I love civil engineering so much is you actually get to see that societal impact on what you're doing. So it can be from helping redesign a road or constructing one, or managing. For example, this summer I got an internship with a company down in Houston, Texas, where they were doing an addition/renovation project on a high school. And so being able to kind of see everything from start to finish, and then being able to see how that influences people's lifestyles is a really neat experience, and something I really love about school.
Yeah, great. Yeah, thanks for pointing that all out. Really great. Okay, Cal, you're up. Let's hear about your project.
Hey everyone. So my name is Cal Murray. Like I said at the beginning, I'm working for a general contractor down here in Houston, Texas. I also just saw a couple questions pop up in the chat that
Okay.
probably I might be able to shine some light on.
Okay.
The one was, what's the difference between civil engineering and construction engineering? And then is choosing one emphasis prevent you from working on another? No, not at all. I was actually a hydraulics and hydrology emphasis when I was in college, and then I ended up working for a general contractor. That being said, I was able to take environmental classes with my hydraulic classes and be able to dual a minor in there with that. So if you're interested in something, you can by all means take that. Sue can probably shed a little bit more light on the curriculum down the road. I don't know if we're going into that much detail or not, but it's the civil program really allows you to kind of explore a lot of your different interests, which I guess is a nice segue into I am down here in Houston, Texas. Sue, I think you can go to the next slide. I think I have a picture of it. I'm currently on a bridge replacement project. So this is a picture of the bridge. It is replacing a tollway bridge that is over the Houston Ship Channel. And so what it is a 1,320 foot main span. So in between those two pylons that you see there on the screen is 1,320 feet. The bridge is 175 feet up above the water. When it's all said and done, the pylons are going to be about 543 feet tall. And it is a precast segmental bridge. So what that means is essentially that the entire road deck is precast off in one of our precast yards. And then what we do is we ship them out on a barge, drop them on a barge, float them out in the middle of the channel. And then we have these big segment lifters that pretty much cantilever off the existing road deck that we've already built. And then we hoist them up into place. And then so pretty much what happens is it's a big seesaw effect. So you hang on one on this side, you hang up one on this side, and then you kind of keep moving. And then they eventually meet in the middle. So I guess I'll do the background. I graduated in 2018 in civil with a concentration in hydraulics. I started working on this job just about a year ago, a little bit over a year ago, in October of 2019. And so I was in estimating before that. But it was, yeah. So a little bit about the project. And this is just, one of the many things you can do in the construction side. Sue, if you want to go to the next slide, it's, yeah, so a little bit about this project is it's bridge. So you can see currently where we're at in that picture on the top left. That's the existing bridge that we're currently replacing. And so you can see where one of the main span pylons is going to be going up in its place. So pretty much how our project is phased is we're going to build one, pretty much transfer over traffic to that new one, and then we're going to be demoing out the existing bridge and building a second identical bridge in its place. So it's going from 4 lanes, 2 lanes going each direction, up to 8 lanes, 4 in each direction. And what it also does is it pulls back the pylons outside of the channel, so they can go in, they can dredge, and they can make it deeper, and they can make it wider, to essentially allow the next generation of overseas tankers to be able to go through there. The bottom right is you can see our pylon jump form system, which you could literally take a college course on and still not understand all of it. It's kind of one of those things that you're out there and it's you're in the field, you're working with the superintendent, pretty much how structures works, and at the same time you're also having to take a look at this, be like, yeah, I think this will work. Why don't we go this direction? But if I could steal the screen real quick, let me
go ahead and stop sharing. So you should be able to share now.
Cool. So I have a time lapse of what this pylon jump form system looks like, which I'll kind of narrate a little bit. But you can see we've started with our cofferdam around here to keep all the water out. And so what you're seeing right now is we're working on our deep foundation work. So you can see that we've started to have all these drill shafts that are poking their heads out here. And so what these are 10-foot concrete diameter shafts that go about 270 feet down into the earth. And so this cofferdam around it is to pretty much prevent the water and the earth from caving into it. And so you're going to start to see all the rebar popping up in here pretty soon. And so we poured these in 2 lifts. The first one was like 6,300 yards, which is a lot of concrete. And then the next one was about 5,000 yards. So normally if you're pouring your driveway, that's maybe 6 or 7 yards of concrete. And this was north of 10,000. So it's just really cool what, civil engineering allows you to work on. And so here you start to see the actual pylon start to take form, and the jump form system start to go there. So that jump system, I can stop sharing here because that's pretty much where the video ends. But that jump form system is going to go all the way up to the top there at 540 feet. What I liked about construction is, you're saying, oh, I'm going to build a bridge, but it's kind of hard to know what that entails. So we're going to, end up putting a tower crane on the side that we had to, get coordination from the Federal Aviation Association, because it's going to be lofted at 675 feet up. I mentioned this, we had a precast yard, so this is actually all on site as well. We're precasting these segments, and each of them weigh about 300,000 pounds. And so we have these massive, you can see the big yellow crane on the top one and the smaller, but still massive blue crane up on the top there. So pretty much what that, we lift those, we throw them out in the channel, and we lift those in place. So you can go to the next one. So some of the stuff that I've had a lot of involvement, which has been fun because my degree was in hydraulics and hydrology, was we were working on the trestle, which is pretty much how you get the cranes out over the water, and then you can drop the segments down in there. So, I mean, there's, you really use a lot of your degree because in the, just driving the trestle, there's a lot of geotechnical calculations that you need to understand, the geotechnical design that you have to understand. Then there's, there's obviously structures in here. There's environmental, because, you have to make sure that you're following the environmental regulations and all that kind of stuff. There's, there's pretty much everything you learn, you're going to touch on at some point or another. So this is, the project's multifaceted, which is also nice because it kind of allows you to do a lot of different stuff. But with the Purdue civil engineering degree, there's really a lot of different directions you can go, and there's a lot of different stuff that you learn. Sorry, my manager's hooting and hollering right now. This is another picture of the trestle. I was the main field engineer out here building this, and that's a year out of school. But pretty much what Purdue teaches you, and I mean, not even necessarily in the classroom, but also out of the classroom with working hard and whatnot. It really prepares you to be able to go far. So I was the main field engineer with just, it was me, the superintendent, and the crews out there. And, at the end of the day, it was honestly just a lot of fun to be able to be out there and to be building that and stuff like that. So I think that's all that I have for those slides. But if anyone has questions, I guess, specifically about, what using your degree out in the construction side of things looks like, you learn a lot of the design side of things in the classroom with the civil engineering degree. But it's, if you're interested in being out in the field and being able to, kind of have to post up in your truck and do some, real quick calculations to make sure no one's going to be falling in the water and stuff like that. It's absolutely something. I don't think you can see it in this picture on the left, but in order to be able to access the side of that, we quickly, it was just me working with our welding foreman to come up with a little overhang ladder. So the guys could be able to just kind of hop over the side and be able to work there safely. And so it's, quick little stuff like that it's like, well, I don't know how to put numbers to this, but, I can take a crack at this here and there and, make sure that things are going to be all right.
Cool. Great. Keep sending questions in the chat. All appreciate it. Caitlin, I think you're up. I'm trying to make the thing go forward. There we go. Go ahead, Caitlin.
All right, so like I said earlier, I'm a structures emphasis. I'm a senior. I'm going to graduate this May, and I have the minor in building information modeling. If you want to go ahead and go to the next slide, you can. So these are some images from my internship with Stantec, which is actually mostly hydraulics and hydrology focused. The office that I went to work with did mostly those sorts of projects. So this is just one of the types of projects that I was able to work on. First of all, one thing I want to say is I didn't take hydraulics or any water related class prior to doing this internship. I had no knowledge of hydraulics or hydrology. So one thing I would recommend is not to be afraid to apply for internships or opportunities that you feel you might not be capable of because you don't have prior knowledge to do it, because they will train you to do it. And they know that you are an undergraduate student and that you're a freshman and sophomore. So what we were doing here is we were doing floodplain modeling for lots of different creeks and rivers for a flood insurance company to determine how much certain people or businesses or whoever owns all these little buildings that you can see down in that middle picture, the little black squares are actually all buildings, how much they should be paying in flood insurance. So what we would do is we would use these topographic maps to model this creek, and we would actually have to go in and cut out to the creek channel depth because these were actually noting the water surface level. So that was like the initial thing we had to do. And then we had to go in and model all of the roads, bridges, significant elevation changes. This is all on the computer. And then we would also have to model in over the levees, anything that would obstruct the water flow. And then we would develop simulations to run where they would be either higher levels of flow with really high levels of rainfall. So what we would do is we would run what's called a 100-year flood, which was the worst type of flood that can run in a 100-year period, or we would run a 50-year flood or a 20-year flood and develop like what areas would experience flooding given that amount of rainfall, and then turn that information over to the flood insurance company. So you can see up in the top right picture, it's kind of, I got that one off the internet because I didn't have a picture of when it's actually filled in with water, but that's somewhat of a good representation of kind of what this model in the bottom picture would look like had it been filled up with water. It was definitely something neat to look at. You can look at like time lapses of like how many hours into the rainfall that when it would reach a peak of number or amount of water. So it's really cool visual design that we got to do there. And then in the bottom right picture, you can see my very first project in CGT 164, which you take as any kind of any emphasis in civil engineering. It's a complement or similar course to CGT 163 that everyone else takes. So I really enjoyed that class. I decided to go on and get the minor in building information modeling, which is focused on using that program, which is featured in that bottom right picture, which is Revit. And you can see in the top left picture, my actual final project in CGT 460, where I worked with a group of maybe 9 other students to develop this model of WALK. So this is actually a model that we developed where every little component in this picture was actually put in place by one of us students. And then I was actually tasked with doing all of the mechanical modeling in this. I've also done plumbing models in buildings. We developed plans for all these buildings. whether it's like an architectural plan, a plumbing plan, an electrical plan, and we had to place each and every outlet where they're supposed to go. So that's, this isn't required to take more than CGT 164 for a civil engineering major, but I found it to be really helpful. A lot of employers that I've talked to about getting this Revit minor, basically, they've said it's really helpful because a lot of companies are starting to move toward using Revit more than CAD, and a lot of current professionals don't have much professional training or experience with CAD or with Revit, sorry. And they've said like actually having someone with that professional training would be helpful to bring into their company. So if you're interested in either the structural or architectural engineering side and you decide to do civil, I would greatly suggest doing something with this minor, or even just taking 1 or 2 additional classes that go toward the minor. And then if you have any other questions about that, please feel free to ask me in the chat or stay on later. And then in the other 2 pictures, you can see pictures from the CSAC Career Fair and all the, about a year or 2 ago, CSAC class. CSAC stands for Civil Engineering Student Advisory Council. It's one of our student organizations. There are multiple other student organizations that you can be involved with. This just happens to be the one that I'm involved with. And we mostly focus on planning and running events for students to get involved with other students or faculty, professors, the industry, the community. So you can see in the bottom left picture the career fair that we run every year, and we have about 130 companies coming looking specifically for civil engineering students. So there are a lot of opportunities there for you to find a company that suits your interests, that is looking for students exactly like you. So that's one really big perk for civil engineering here at Purdue.
Oh, I said I was unmuted. I was muted. Sorry. Thanks, Kayla. Good Lord.
Yeah, no problem.
All right. Whitney, you're up. And FYI, everybody, we are at 6:08, but we're good. Go ahead, Whitney.
Hi. Okay, so sorry, I was trying to finish up answering a question. So I personally work in water resources, like I was talking about, in drinking water design. So I like to kind of divulge into what a day-to-day is for a design engineer. Cal is one of those people that does construction engineering, and so he works a lot of time in the field. But whenever you're considering a civil engineering degree and a job in civil engineering, you kind of have not just the construction option, but also the option of being a consultant or with a design firm. And that's what I chose to do. So I'm looking at about probably 60% of my time. So 3 days out of a 5-day week, I'm going to be in the office designing things. 1 day out of the 5-day week, I'd probably be meeting with clients and talking with them about the things they need me to design. And then 1 day out of the 5-day week, I'd be actually in the field watching things that I did design go into construction and helping to help that on-site representative, that resident project representative, which is more of what Cal's doing, with anything they might need, and kind of be the liaison between the design and that person, and just kind of answer questions, but also get questions from them and take them back to my firm. And that's just kind of how my firm works, but it should be pretty similar amongst other design firms. And then what I specifically do on a day-to-day basis is, as I said, drinking water. So right now I'm working on several different projects to design drinking water treatment facilities to either from the ground up. We have a new town in Indiana, La Paz, that's going to be going from all groundwater wells at each individual home to having an actual entire water system for their community. So getting the water out of the ground for the entire community, treating that water, and then getting it to all the homes. That's one type of job I might do, but another one might be just a bunch of relocations of water main, or a new treatment process at a treatment plant, because now all of a sudden the groundwater has sulfate in it and we need to figure out how we're going to treat it. So that's kind of what I do on a day-to-day. Oh, and here's some pictures of a water treatment plant that I've been working on, that's in Frankfort, Indiana, pretty close to Lafayette. And then there might be some more. That is a on-site generation facility, which is super cool. It basically takes salt, like table salt, and water, and shoves electricity into it and breaks up the salt molecules into chlorine and hydrogen from the water, and you can actually make bleach on site. So it's how you would make bleach to sanitize water in a normal way, but now you can do it on site and at your treatment plant, and that cuts down a lot of the safety concerns with traveling with gas and chlorine gas and bleach, which are both extremely flammable and very dangerous. And then those are just some other systems for pumping and stuff like that. These are like each one has its own nuances, but these are like my everyday things that I see.
Thanks, Whitney. Jasmine, you're up. Let me know when you want me to forward slides, okay?
Okay, sounds good. Okay, so I forgot to mention earlier, but I do have 2 minors. One is in building information modeling, and the other is in sustainable engineering. You can go to the next slide. So last summer, I was an intern at AECOM in Indianapolis. I was under their transportation department. I am an architectural engineer, so I know some of you guys in the comments area were wondering how transferable is these emphasis areas. So it is very transferable. The information that you're learning can be used across all civil engineering. So it's very nice that civil engineering is broad and diverse, but if you want more experience, you can get that experience in different ways. So in the transportation department, I worked on providing uninterrupted power supplies to traffic lights. So if you look at the bottom left picture, every traffic intersection, basically just the power, but say there's a bad storm or goes out, I was providing uninterrupted power supply so that the traffic would not stop and the traffic would continue to flow smoothly. Next summer, I actually just secured an internship with Bechtel as a project controls intern. So that basically means I'll be doing the scheduling, cost estimations for the project, and making sure that the project stays on track. Post-graduation, I am looking to do a master's here at Purdue in architectural engineering. I know some people in the chat were wondering about architecture and architectural engineering. I was right in your shoes when I was a first-year student. I was unsure what I wanted to do. I actually talked to a lot of people in the industry of architecture. And I think that with my building information modeling minor, I get to satisfy that need of architecture by designing buildings in Revit and just knowing how to make sure that the construction people know what they're doing, the engineers know what they're doing. It's like mending both the 2 loves that I have, but I don't think that architecture was necessarily for me because they focus more on just design and making sure that everything is fitting the design requirements, but not necessarily the engineering side. So if you want to do architectural after graduation of undergrad, but doing engineering for your undergrad, I think it would be best just to look into that just to make sure, because you'd have to do a lot of catching up because you didn't do it for your undergrad. That's what I found out when I was doing my research and everything like that. So just a heads up, you might have to do a lot of catching up and it might be a little bit more rigorous master's program. With all that being said, I hope I answered all your questions, but yeah, so next slide. Okay, so these are just some of the places that I visited before college that kind of solidified, why I wanted to do architectural engineering. Just looking at all this architecture across the world, the left picture is in Vienna, Austria, and then the right pictures are in Slovakia. So it's just like This, I don't know if you could tell, but I'm like 150 yards out from the palace, but it's a gigantic palace. So it's just really cool to see. Next slide. And then these pictures are from when I went to Dubai, and then the right side is from when I went to Budapest. So Dubai on the 160th floor, I think it's still the tallest building in the world, but you go 160 floors in 60 seconds. So it's just like really cool to see how they did that. And civil engineers across the world worked on this project to make it the largest building. And then when I went to Budapest, I didn't put a picture here, but the parliamentary building, beautiful. Like it's just phenomenal how much like detail they put into it, and then just all the work that went into it years and years ago. This is from hundreds of years ago that was built. So yeah, it's pretty cool.
That's awesome. So what the 160th floor, what building are you in? Are you in the Burj?
Yeah, it's the Burj Khalifa.
Yeah, that's like so cool. It's one of the tallest, it is the current tallest building in the world. So it's just such an amazing structure and so much engineering and design and all aspects of it. So really, really cool.
It
So
was
I know
actually named after Sue Khalifa.
it was not named after me. Well played, Cal. But I do share, a namesake with it. So hopefully I'll get to visit at some point in time. I know there's been a number of questions coming up in the chat, and Jasmine, thanks for addressing it. So I thought I think some of them were like structures versus architecture and what's the difference, right? So a structural engineer is going to look at the skeleton of what holds something up. What is that something? A building, a bridge, a tank, something. It could put insert any object. That's what a structural engineer is going to do, right? So if you're looking for designing the columns, the beams, the walls, the floor systems for a building, that's a structural engineer. That's what I did in my career. Now, if you're interested in like what Jasmine was talking about, the building systems and the energy efficiency and the sustainability and resiliency of the systems of the building, that's more along the architectural engineering side of things. So hopefully that clears it up. So what other kind of questions are out there, team? What should we be addressing?
I saw one, which it's a little bit of a concern that I think you guys probably all have a lot. Someone was talking about, getting jobs and that kind of stuff with, all the coronavirus and economic slowdown that's happening. Something that's nice and that's reassuring about the industry with civil engineering and construction and that kind of stuff is usually a lot of the times they'll publish stimulus bills and that kind of stuff. And a lot, almost in every single one, there's a significant portion that's dedicated to investment in infrastructure, new infrastructure projects, expediting infrastructure projects. So in like, as an example, the LaGuardia renovation is $6.6 billion, I think was the most recent price tag it had. And in an effort to try to get money back in the economy, the governor of New York literally started just pretty much writing blank checks to try to speed up things, just to try to pump more money into the economy there. So what's nice is that, with everything going on, the civil engineering industry is resilient. It does have a lot of influx of money. And so it is a stable industry to be getting into. So just, I know it's kind of a weird time to be alive in the world with everything going on, but I know that is probably a concern for you guys coming into, coming into college right now. But I've been on the recruiting side. And so I know for a fact that we're still hiring, we're still finding great candidates at Purdue. And so I know that it is a little nerve wracking, pretty much trying to figure out, what am I going to do as a career right now? But I just want to let you guys know that civil engineering is a resilient industry. And there is a lot of, there's a lot of stuff that happens there.
It's very helpful, Cal. Thanks for shedding some light, because I know that's probably a question on most people's minds. So team, what other kind of questions are rising to the top? I think I'm still seeing some questions about CEM versus CE. Is there anything else that needs to be flushed out? Go ahead, Camille.
I just saw one asking about CE or CEM regarding like being on job site more depending on the degree. So with construction, it really involves which career path you can go on to. So the main ones are superintendent or project manager. The superintendent pathway is through the field engineer. So what Cal's doing, so you're mostly on site for most of the time. Well, when you go into CEM, that's the management side of things. So that's more the project manager role. And you do get to be on site for some of the time, but as I've been told, it's kind of like the best of both worlds in the sense that you get the office experience regarding the paperwork, learning different contract types, making sure the schedule is on track and all the office kind of stuff, but also you get to be on site and watch the progression.
Yeah, kind of to go off that, my so I'm working as a field engineer is my technical title. And so I would say that I'm in the field about 50-50, 50% in the office, 50% in the field. And so it is a nice balance between, you know, using your degree, kind of putting to paper what you actually know, and then also at the same time, being out in the field, taking a look at the design with a practical approach and saying, all right, how are we going to actually make this work? You know, we got to move this thing 2 inches this way and it weighs, you know, 85,000 pounds or something like that. And so it is a very interesting, you know, give and take between, you know, being out in the field and being in the office.
So I'll go ahead and share the QR code while you continue answering questions.
Thanks. Yeah, I saw those pop up, so I thought I'd close out. So I saw a question come through about architecture. So Purdue does not have a school of architecture. You could not minor in architecture at Purdue, but you could go to another university for a grad program for architecture. It's not uncommon, especially in the structures industry, to get a degree in civil engineering structures and get another degree as an architecture degree, or in kind of they flip. Some people have undergraduate architecture and a master's in civil engineering structures. So, but just try to address that question. What other questions are out there, team? So to everybody that's still waiting, I know students, you're trying to get the QR code and move forward with that. Feel free, I don't know how many people are still around, hundreds, but for those that want to stick around, feel free to ask questions in the chat, or if you want to unmute yourself and chat with us, we're happy to answer your questions. Great, thanks. Appreciate people that are saying this was very helpful. Wonderful.
Hello, could I ask a question?
Yep, go ahead.
So my question is it true, the statement that if I majored in CEM, there would be certain projects or certain projects that I would not be able to work on, but I would be able to work on if I had a civil engineering major? Like, is there an area of knowledge that it goes in that civil engineering major that the CEM major doesn't cover because they're more focused on the management side of it? Like, is it less knowledgeable academic in some areas of the major? I don't know if I explained it pretty well, but
yeah, I think I get it. Cal, you want to hit this one up? I mean, I can, but I think you'd have a better perspective.
Yeah. I would say no, not necessarily. I think that from a core curriculum, and I think that Sue might be, you know, able to elaborate on it too, but from a core curriculum standpoint, CEM and CE are very similar. You guys are going to have very similar, you know, you're still taking the same structures classes, you're still taking the same, you know, transportation classes, you're still taking, you know, the same materials classes and that kind of stuff. It's just the way the actual curriculum is structured. CEM focuses a little bit more on actual construction management classes, and then also, with actual management classes out of Cranert. That being said, so I was a civil, and I still took, some of the same construction management classes that CEM students take. I still took Management 200, which CEM students take. So I wouldn't necessarily say that if you were to go the CE route or the CEM route, that one or the other is going to necessarily preclude you from being able to get involved on a certain project that you would like to get involved in, and stuff like that. I know that civil, if you're going to be more geared to go down, a master's of science route in civil, and stuff like that, then I know that civil itself, you can get a lot more. You can work with a professor on, if you're passionate about concrete mix design or something like that, you can work with an actual one of our concrete professors over the summer or during the semester and stuff like that, where a CEM puts a higher emphasis on actually getting you out in the field and being able to see the industry in the day-to-day. And so that's my understanding of, how the kind of differences work. So I wouldn't say that there's necessarily a difference, between the academic portions, or, that one lets you do this and whereas the other lets you do that. They really do go hand in hand. You're going to have CEM kids in your CE classes. You're going to have CE kids in your CEM classes. So they are very similar majors. It's just like what I said, CEM puts a little bit more of an emphasis on, the actual construction side of things, whereas CE is a little bit more broad with different kinds of breadths and emphases and stuff like that.
Yeah, I agree. And I was going to share my screen to, Hernani, can you see the curriculum
Yeah,
flowchart? Yeah. So, yeah, CE and CEM share faculty. They take similar classes that are cross-listed, right? It's got a CEM number and a CE number. What's different about our program is in a CEM, it has a required internship. We don't have requirements for internships, but most of our students do have internships. And you can see here in yellow, these are our technical electives. So as a civil engineering student, we have 10 courses that you can choose what you want to take. So as a civil engineer, we're graduating you as a civil engineer, right? So you get a breadth of knowledge about all aspects of civil engineering. Like Cal was saying, he's not going to do the geotechnical engineering design, but he better be able to understand those geotechnical engineering reports, right? He's not going to design water systems, but he should know enough to be able to relate it to the work that he's doing. And in civil engineering, you get to do that because the breadth courses are a way that our curriculum basically requires you to take different pieces or different aspects of civil engineering. So any one of those 9 areas, that's where you do it. You take kind of an introductory course as your breadth course. It gives you a basis because, like I said, you're graduating as a civil engineer. Like my degree is this degree, civil engineer degree. I went and specialized in industry and designing buildings specifically, but my degree is fundamental so that when I got out, I was able to understand all the different, because when you get in the field, all the aspects of civil engineering, they all tie together. Like there's so much overlap. So does that better address your, or not better, but address your question?
Yeah, definitely.